Motion of a vehicle on a circular track. The circular track are often seen banked, that is, the road is provided an inclination sloping down towards the center of the track. Here, the cars are moving with equal speed on a horizontal road. The cars now take a turn, but one goes on flat road and the other on a banked road. The one on the flat road has to reduce its speed. Why do you think the car moving on the flat road has to slow down? When a car takes a turn, it moves on a circular path, and therefore it requires a centripetal force. While moving along the circular path, the direction of motion of a body at any instant is along the tangent to the path at that instant. Due to continuous change in direction of motion of the body, there is a change in velocity of the body, and hence it undergoes an acceleration called centripetal acceleration. Let us study the dynamics of car turning on a flat and banked road. While the car is moving on a flat circular track, three forces act on it. The weight of the car, mg, acting vertically downwards, normal reaction, N, of the road on the car acting vertically upwards, frictional force, F, acting along the surface of the road towards the center of the turn. The centripetal force required to keep the car in motion with speed v in a circular path of radius r is given by mv square by r. This force is provided by the force of friction. If the force of friction is sufficient to provide the necessary centripetal force at a given speed, the car will successfully negotiate the turn. Thus, the condition for successful negotiation of the turn is that the speed of the car should be less than or equal to under root mu rg, where mu is the coefficient of friction between the car tires and the road. The car will skid away from the center if the speed of the car increases beyond the maximum value. This happens because the centripetal force required at such high speed cannot be provided by the existing frictional forces. Excessive braking may increase friction but will cause the wear and tear of the tires. The car may also skid if the friction between the road and the tires is reduced, as on a slippery ground after the rains. The skidding may also occur when the car takes a very sharp turn at a high speed. During the motion of a car on banked track, the forces acting on it are weight of the car acting vertically downwards, normal reaction of the road on the car acting perpendicular to the banked track, frictional force between the banked road and the tires parallel to the track sloping downwards. Here, the centripetal force is provided by horizontal component of friction F cos theta together with the horizontal component of normal reaction N sin theta. Hence, a greater force directed towards the center is available to support the required centripetal force. The car can, therefore, negotiate the turn at a higher speed on the banked road as compared to that on the flat road. Moreover, banking the circular track will reduce the dependence on friction, and wear and tear of tires will reduce considerably. Bending of cyclist. Here is a cyclist riding his bicycle first on a straight road and then on a circular track. Why does the cyclist bend towards center of the circular track? Let us study the forces acting on the cyclist while he is negotiating a turn. Gravitational force mg in vertically downward direction and normal reaction acting at an angle theta with the vertical are the two forces on this cyclist. The vertical component of the normal reaction n cos theta balances the weight of the cyclist together with the cycle. The horizontal component n sin theta acting towards the center of the circular track provides the necessary centripetal force. Thus, a person cycling at a speed v while moving in a circular path of radius r must bend at an angle theta such that tan theta is equal to v square upon rg. The speed at which the cyclist moves on a circular track will decide the angle at which it needs to bend. Maximum speed at which it can negotiate a turn is equal to under root rg tan theta. In actual practice, safe speed is higher due to friction supporting n cos theta to provide the centripetal force.